Hello, my name is Jongwon. In this project, I create a 3D fluid simulation that represents water inside a cake pan using OpenGL and particle-based physics. My contribution to this project focused on improving the realism of the fluid behavior and the interaction between the water particles and the tilted pan. Specifically, I implemented several physics features. I added y-axis tilt support so the pan can rotate in 3 dimensions. I implemented boundary constraints so particles cannot escape the pan. I created collision handling between particles and the pan surface. I added particle repulsion so water particles push each other apart, which helps simulate fluid behavior. I also implemented sudden tilt detection, which causes the water to splash more aggressively when the pan is tilted quickly. This variable stores the tilt of the pan along the y-axis. Previously, the pan only tilted along the x and z-axis, but I added this variable to allow rotation around the particle axis as well. This makes the simulation more flexible and allows the water to react to tilt in 3 dimensions. This line applies the y-axis rotation to the cake fan using OpenGL. The function GLRotateF rotates the current transformation matrix. The second, third, and fourth parameters represent the axis of rotation. In this case, the axis 0, 1, 0 means the pan rotates around the y-axis. This line creates the water system with 400 particles. Each particle represents a small portion of water in the simulation. A larger number of particles improves the visual density of the fluid and produces more realistic movement. This line updates the physics of all water particles each frame. The current tilt of the fan along the x, y, and z axis is passed into the update method. Inside the update function, the particles adjust their velocity and position according to gravity, tilt direction, collisions, and particle interactions. These variables define the physical limits of the cake pan. The boundary variable represents the horizontal limits of the pan along the x and z axis. The bottom variable represents the lowest vertical position allowed for particles. These values ensure that particles remain inside the pan instead of falling infinitely. This calculation determines the height of the tilted pan surface at the specific x and z coordinates. Because the pan can tilt, the surface is no longer perfectly flat in world coordinates. The formula calculates the y value of the tilted plane using the plane's normal vector. The mathemax function ensures that the computed surface height never goes below the defined bottom limits of the pan. This line simulates the effects of gravity along a tilted surface. When the pan tilts, the water particles accelerate in the direction of the slope. The sin function converts the tilt angle into a force component along each axis. This allows the water to flow realistically towards the lower side of the pan. This code checks whether a particle has moved below the surface of the pan. The cake pan position y function calculates the height of the tilted pan at the particle's position. When a particle hits the pan surface, a collision response is applied. The particle's vertical position is corrected so it rests exactly on the surface. The particle velocity is reversed and reduced to simulate energy loss during impact. A small random value is added to create splash-like variation. The horizontal velocities are also slightly damped to simulate friction with the surface. These conditions prevent particles from leaving the cake pan. If a particle crosses the boundary, its position is clamped back inside the allowed region and its velocity is reversed. This stimulates the particle bouncing off the side walls of the pan. This applies damping to the vertical velocity of particles. Damping gradually reduces motion over time, preventing particles from bouncing forever and making the simulation more stable. This condition checks if a particle has moved outside the veiled simulation region. If a particle goes far outside the pan or below the allowed depth, it is flagged for removal to keep the simulation stable. This method simulates interaction between nearby water particles. In real fluids, particles push each other apart due to pressure. This calculates the square distance between two particles. The repulsion force is inversely proportional to the distance between particles. This means particles that are very close push each other away more strongly. These variables measure how much the pan's tilt has changed since the previous frame. If the tilt changes rapidly, it is detected as a sudden tilt event. When a sudden tilt is detected, random velocity is applied to particles. This simulates a splash effect when the pan is moved abruptly. These variables store the tilt values from the current frame. They are used in the next frame to detect changes in tilt and determine whether a sudden tilt event occurred.